Hi everyone, welcome very much for coming to today's webinar. So before I start everything, before I go into the content and details of the webinar, I would like to point out a few things. First of all, this webinar is going to be recorded for the session and they will be uploaded on YouTube. And sometimes we do replay some of our webinars. Um, and you can actually ask questions during the sessions, and I try my best to answer them. But because these webinars might be replayed in the future, so sometimes I do get some of the questions and emails to me saying that you didn't answer my questions during the session. Is maybe because that session is not really the live session, but it was a recorded one. So please look at the date here. Today is 21st of September 2022, and if that's the date that you actually watch this webinar, that means that it is the live session. The other thing is that you're welcome to raise any questions during the session. I'll try to answer them at the end of the webinar because I usually packed a lot of content for my webinars. So I will answer them at the end of the session. But don't worry if your questions aren't really answered, or maybe you attend the recorded session, just send me an email. I will give you guys my email address at the end of the webinar as well. All right, so let's go into today's content then. So whenever we actually talk about management of chemical plants, we're usually focusing on how exactly we're going to run the plants, like um, how much yield that we want from our chemical processes, how much product, and also how do we manage the operation so that maybe the reactors doesn't really overheat or anything. However, all these details and data, usually whenever I go to a plant to do whether a PHA, HAZOP, or some kind of functional safety assessment, or some kind of a alarm work like alarm rationalization or some kind of detailed alarm designs, I don't really see a lot of the informations, especially informations about the modifications to the plant, or even sometimes the P&IDs aren't really up to date, or maybe there's no record about whether there's any changes to any kind of alarm attribute. The operators can change whatever they want. So because of that, while you might think that this is a common sense to actually have these kind of records, to have these kind of documents, but they are not really being brought to reality when in practice. And it's just so many times. Whenever I go to a plant, I see the same problem again and again. While I'm also dealing with a lot of data analytics and a little bit of data science myself, so I think that it might be a good idea to bring in some of the data science, very core data science fundamentals into the conversations, into how exactly you want to manage these data or information in your, basically in managing your functional safety system or your alarm system. And I would try to combine and point out how these life cycles of the data management life cycle, how they basically resonate with these functional safety life cycles or the alarm management or alarm rationalization life cycles out there. Specifically, the IEC 61511 and also the ISA 18.2. And this is actually one of the webinars that I'm planning to do, basically trying to combine a lot of the data management or data science ideas with functional safety and also with alarm management. And today we will mainly be focusing on the data flow for your whole project or for your whole plant, based on whether it's safety system or its alarm system. A little bit about myself first. So my name is Paul Chan. I was based in Hong Kong. I was part of the Asia Pacific office, but I was transferred here to the US headquarters in 2018, and I've been here for a few years already. I started out with the process safety from on the HAZOP and also the LOPA side, the seal selection side. I was put on basically a HAZOP and seal selection workshop in Seoul, South Korea for 3 months. And after that intense workshop, exida decided to hire me as a technical engineer, as a consultant, mainly because my background wasn't actually in engineering. My background was actually in biochemistry. So, but I was able to basically impress the people by following the process and able to read P&IDs. And then afterwards, I take on a lot of the certificates like CFSP certificates and some of the alarm rationalization certificates, alarm management certificates, and also cybersecurity certificates. And after that, I've been very active in other part of the risk analysis for the safety system, like seal verifications, and also I facilitate a lot of the alarm management projects, and sometimes I also facilitate a HAZOP and seal selection workshop as well. And I also take part in the cybersecurity audits for those industrial plants as well. And these are actually the core business of us, of exida. We do functional safety, alarm management, and cybersecurity. And it is a global effort to actually push for the automation safety in that sense. As you can see, we have different offices scattered around the world. A little bit more about our company. We believe we are a customer-focused company. That is actually true for most consultancies, I would say. And as a consulting firm ourselves, we definitely need to focus on our customer. But we are a little bit more special because first of all, we have our own tools, we have our own software, which called Seal Excellencia, and we have different kind of modules for help you to basically bring everything together. And we also have lifecycle services where we do the consulting work like facilitation of HAZOP and LOPA while using our own tool, our own software. And also we do certifications as well. It can be certification for hardware, certifications for cybersecurity, or even certifications for personnel as well. And other than that, we also believe us as a kind of academy in the sense that we try to educate people about safety as well. We have a lot of books on management side or on very technical side, like the safety instrumented system design, where we actually use the most accurate form of mathematical method for seal level calculations using Markov modeling. We also have our own database for all the safety certified equipments like valves, like PLCs, or any kind of transmitters as well. And a little bit more about our certification schemes. So we have certifications based on different IEC, ISO, or even ISA standards. Like we have certifications for IEC 61508, we have certifications for IEC 61511 and ISO 2662. For those who understand and also know about the IEC 61508 standard would know that IEC 61508 is actually the mother standard as the big umbrella standard for functional safety, where you have specialized standards like IEC 61511, which is just for and specified for process industries, or the ISO 2662, which is specific for the automotive industries. So we have different kind of certifications. The IEC 61508 certifications is mostly for the hardware and any kind of instrumentations, mainly because they might actually use that particular hardware in different contexts. Maybe they can be used in chemical plants, or maybe they use it on other kind of applications, or maybe in a machinery in that sense. So that's why we use the IC 61508 standard to certify those kind of instrumentations. And we also have IC 61511 and automotive certifications, and also we have the cybersecurity certification as well. I'll go into that a little bit more detail later. Of course, we have the machine safety certifications and machinery safety, which we refer to right here would be big machinery like a big drilling tower or tunnel digging and stuff, rather than like a whole plant, but it's everything like a compact into a big machine that's for some industrial applications. And other than these kind of certifications, we also have the personnel certification program, basically certifying you to be capable and also accountable and be able to do these functional safety work in that sense. And also, we are actually a global leader in terms of our certifications. In terms of the devices that are certified by us, we're actually catching up and even surpassing our main competitors, the Truth. If you would know that Truth is actually a company of a very, very long history. So it is a really big feast that we have, a feat we have actually performed and we have actually achieved, that we have overcome 20 years head start to become actually the leader right now in terms of the certifications for all the safety devices. And other than that, we are also a very global leader with the to actually push for the automation cybersecurity certifications. And we actually team up with the ISA to actually push for these kind of cybersecurity certifications for industrial applications. For those who understand IT and OT concept, IT would be information technology and OT would be operational technology. The IT cybersecurity will be mainly focusing on safeguarding information, trying to safeguard information in a way that they don't get leaked, they don't get compromised in the sense that they are being stolen, and the privacy problems as well. Privacy and also piracy problem as well in that sense. But for the OT side, because OT, we are talking about operations. We are talking about how to operate a plant. A lot of the time, the cybersecurity concerns and threat, we are not really thinking about information. Of course, we don't want them to be stolen for information for like the plant, like the whole plan, or blueprint of plant. We don't really want to basically let that leak. But a lot of the time, we want to safeguard the functions within the system, especially for the safety functions. If they do something, the hacker did something in a way that basically compromise the safety system, then you will have a safety incident. So it's more about whether there is some kind of attack, whether there's some kind of a compromisation of your whole system, like what happened in certain nuclear refinement plant in Iran, where they basically their PLC was compromised to do the refinement of the uranium salt. So that's something that we should take into account, or we should be focusing on when we talk about automation cybersecurity. So other than this, these kind of certifications, we, as I've mentioned, we are also very proud of our Excellentia suite. We're very proud of our software. In fact, we are one of the first, and I believe we're still the only one that actually uses Markov modeling to basically calculate your seal level, which is basically embedded in the Silver module. Markov model, the concept is very, very complicated. But when we talk about the mathematical methods, basically it's an expansion of a different kind of matrices. And you can actually, as I would quote our CTO, Iwan here, that you can actually do it on your Excel sheet, but it can be very cumbersome to do it if you have a lot of different votings, like 2 out of 3 or 4 out of 3, stuff like that. So that's why we provide this particular module for people for actually do the most accurate calculations for silver, for your silverification. And other than silver, we also have other modules like seal alarms, which is for alarm rationalization and alarm management, seal stat for your operations to basically keep a record for your maintenance and also all the failures. We have facts for PHA, the low perks for low perm, seal selections, we use seal select, and also SRS as well. So I'm going to talk a little bit more later in the slides because these are very important points I actually want to bring out in this particular webinar, especially when it comes to data flow. What we are very proud of this Excellentia suite is because they are different modules that's being basically encompassed within one big Excellentia suite, so that all of the data can actually be easily flowing from one end to another end. And we have different modules for different phases or different activities in the life cycle, like the PHAX for the process hazard analysis, the HAZOP, or the silver is for the silverifications. So these information can flow into other part of the software very easily. And that is actually what we want in a way to safeguard all these information, to basically trying to have these kind of data all combined or contained within one place to archive it, which is a very important concept in data management within the data science. And also we are able to like from PHA Pro, we can import data, doing some data cleaning, we can import that very easy, export from the PHA Pro to the our PHAX tool in order for all these data to be safeguarded within one place. And other than that, we also have tools specific for the OEM side, the original equipment manufacturers, which is mainly actually about talking about failure rates and also failure modes. In fact, we also pioneered a method for deriving the failure modes and related to diagnostics for different instruments using the FEMIDA. Is actually derived from a kind of a military method. I believe back in the 50s, the US military used it to basically for strategic planning for failure modes, which is FEMA. But we combine one more I would say mode of thinking, philosophy, the diagnostic into it, to actually apply this method into basically coining and also derive all the failure rates and failure modes for the devices that we are going to study. So that's a very brief introduction about what our company is and what we actually do. Now let's go into the main part of today's webinar. So what exactly is data science? A lot of people, whenever they think about data science, they would talk about big data, they talk about machine learning, they would talk about AI, and some actually have the misconception saying that, oh, big data, it also has something to do with the cybersecurity, which it has a little bit relations, but the main purpose of big data is not in a way that related to cybersecurity, but it has complications in a way that it would actually arise some of the threats within cybersecurity. But the main purpose of big data is not in a way to actually for the purpose of cybersecurity in that sense. In fact, data science was a subdisciplinary, and it started in the Department of Statistics back in the 60s, and it started out as a data analysis. So The main part, the main aim for data science is actually for analyzing data, using different methods, using mathematical methods, using the insight of understanding different data set, and also applying some kind of background informations in depending on where you actually apply this particular data analysis on, then you try to solve these problems. So in terms of where exactly you can apply these kind of application domains, you can actually apply it in anything, basically. And that is exactly why there is a recent rise of some kind of very fashionable thing when we talk about data science these days. Because first of all, data science can be applied into anything. It can be applied into business strategies. It can be applied into mathematical modeling for your financial data to maybe do some stock calculations, predicting prices. It has applications for managing even all the documents within your company as well. I know someone who's a lawyer in New York City, and they just hired a data scientist to basically do that, to streamline the documentation process, to push out documentations for everything. And of course, it must have applications in the world of industrial, I would say industrial control systems. But honestly, a lot of the time, I really don't really see them actually catching up in the sense of the OT side, in the sense of the industrial control system side. I always feel like maybe it's because that whenever we talk about industrial applications, or maybe in a way that the infrastructures or the government side, you understand that they usually like to use really, really old systems. And personally, I've been to quite a number of plants that they still use Windows Me, Windows 2000, and I actually feel a bit happy if they actually use Windows XP, honestly. The main reason for that is for cost, because all these products, all these systems were basically discontinued, so they don't need to think about upkeeping costs in that sense. So, and they just don't want to change it because they've used it. There's a saying in engineering saying that if it ain't break, we just don't really mess with it. And that kind of concept kind of creep into the management of these kind of whenever we talk about technology in terms of the applications for these kind of industrial situations. So I do hope that people would actually take it more and more serious about data science, especially at least about safeguarding this data, not losing P&IDs or not losing documents in the long term in a way that they're basically compromising their own safety integrity of that particular plant. So that's a basic idea of what exactly data science is. Its main purpose is basically doing data analysis and therefore safeguarding data, and also trying to understand how exactly we can manage the data is most important. Where machine learning algorithms like clustering, linear regressions, they have their uses, they are tools. But if we do not have the data intact, we do not have the data core intact, all those gimmicks are going to be moot in the long run. So let's go into the life cycle now. So how does the data analytics, how does the data science look at data management? So basically it's divided into 6 different steps: the plan, capture, manage, analyze, archive, and finally destroy. Plan, as any kind of process that you need to have a plan or scope to actually know what you're doing, what kind of data you're dealing with, how would you plan to manage the data. You need a blueprint for that. And then we try to capture those data, to bring these data from different sources. In an industrial, maybe I would give you an example about alarm, then that would be, okay, all these alarms are from local report, all these alarms are from the control, direct download from the control system, or maybe these alarms are from some of the recommendations that raised in some kind of meeting. Could be either HAZOP or maybe some other kind of operation meeting, process meeting. Then we want to capture those. And then we want to manage these data. We need to maintain the data, have versions control on them, and also where and how it is going to be stored, what kind of tool you're going to use it to store it, whether it's in like a paper format, whether it's digital. If it's digital, what kind of database that you want to build for it? Is it SQL? Or is it some kind of a more native format? Is it Excel file? Or maybe it's a specific, a particular software specific format as well. So that would determine how exactly you want to manage your data in the future. And after you have got all these data, now you want to analyze it to solve problems and also make decisions. And that's the analyze phase. And after your analysis, you would actually try to store these data, keep these data for long run and also for the long term and also for the future references as well. So you want to archive them. And then finally, when you realize that, okay, we don't really need these data anymore, then we actually need to find a way to destroy them and also a proper way to destroy them, remove them. Because you might think that, okay, we can just leave it there without any problem. But if it's some of the data are very sensitive data, maybe in the future, if you don't really destroy them, maybe they got leaked or maybe some kind of cybersecurity incident, then they got leaked into the internet or something, then you might actually have some kind of safety incident within your plant. People can use that against your plant in the future in that sense. So that's why a proper destroy or decommissioning procedure should be in place to actually handle these kind of data. There are other variants in terms of the data management lifecycle out there. The US Fish and Wildlife Services, of course, they have a lot of data in terms of their, maybe data on their bird migrations or fish or anything. So they have their own life cycles. The Harvard Business School, they also have their own data life cycle as well. And very importantly, they also have a focus on visualization, because visualization is very important for making business decisions, because data and analysis or data scientists, they need to present these findings and make recommendations to management. And usually management, they don't understand the method. So we need to find a way to visualize them and then to actually present them to the stakeholders. This actually has a very good application when it comes to alarm rationalization and also alarm management in terms of the visualization. I will go into that a little bit more details when I come to that. Now, that is the basic concept about data management lifecycle. Let's go into the functional safety lifecycle now to see how different part of a functional safety lifecycle is actually going to resonate with that 6 big bubble of the data management lifecycle. So this is the IEC 61511 safety lifecycle, which is a little bit different than the IEC 61508, but I would be focusing on the process industry today. So it's divided into 3 main parts: the analysis phase, the design phase, and also the operation. So because this is a functional safety standard, everything related to IEC 61511 has a main focus, which is on the safety system, the SIS system. Some of the output from the analysis phase can have other uses, but the main focus for the life cycle would actually be focusing on how exactly you're going to manage your safety system. So are the data related to the safety system. So that's actually what we're going to be focusing on today. This is just a very brief a top view of the life cycle, I'm actually going to show you something that's a little bit more detailed like this. So the analysis phase, the very beginning of the life cycle, everything needs to start with a plan. As I mentioned in the previous slides when I talked about the data management lifecycle. So everything needs to start with a plan. How exactly you're going to plan for your process design, for your design of your safety system. And that plan is going to create something called process safety information. And that's the data information over there. And after you have the plan, we try to do the PHA, which is a kind of an analysis and also a kind of a capture, and also trying to manage a little bit of the data as well to derive some of the hazards, the consequences, and then so that we can pass them into the lower part, which is basically an analysis of the IPLs, the layer of protections to see whether those safeguards are actually useful or not, whether they can actually be qualified as safeguards or not. And then we can also derive out the hazard frequencies. And because usually when we talk about LOPA, we are talking about IPLs, and we are talking about some of those IPLs can actually be a SIF within your SIS system. So this is usually where we can actually select the particular seal level. The seal level is basically the burden that you're going to put onto your SIF, specific for this particular consequence with the hazards. And by minusing all the other risks that's shared by other safeguards. And they also have some kind of a concept in terms of how much of a tolerable risk that you need to have. So that can actually expand to a whole days of teaching. So if you guys are interested, please consider joining our course, the FSC 101, also 102. We will go into details about different part of these sections and phases within the life cycle. And in this part, we're doing the analysis phase. We're doing a lot of analysis into the situation because we're basically getting the information from the hands-on, and then we try to do a lot of the analysis there. Especially, we are doing a lot of the quantified analysis as well to get to the seal level. And after we got all these information specifically about the target seals, which is basically the seal level that your SIF needs to meet, then we combine with other information. We want to have a particular document called safety requirements specifications. So specifications shouldn't be something that's very alien to engineering. Software engineers use it, specifications to build their software. Hardware engineers use it to build their hardware. Architects use it too to basically build architecture as well. So whenever we talk about engineering, specifications should be in place in a way that it determines and dictate how basically your stuff is going to be defined, it's going to be designed, and also it's going to be built. And this specification is specific for your safety system. That's why it's safety requirements specifications. And here, this is basically the archive for your information, for all the data. And that is basically the analysis phase. This particular specification is extremely important because whenever we're trying to do the design, whenever there is a need for any kind of changes, maybe when we try to analyze the situation, or maybe when we try to capture the situation, when we try to manage a situation, we realize that, okay, it's impossible to basically meet a seal 4 SIF here. So we need to go back to the the LOPA to see if we have other kind of safeguards to basically share the burden to reduce the safe requirement, the seal requirement on that particular sieve. Then in that case, you actually need to go back to the specifications to update that, to properly archive that new data in that sense. And after you have finished all the designs and you realize that the seal level is met, then you can go into a more detailed design, basically design everything and then start testing it within the factory. And after this is done, then everything, the functions, the instrument, the hardware, everything can be shipped to the site where you can actually do the installation, commissions, and also a lot of the validation and the cybersecurity audit as well. And then you can actually try to run it afterwards. And this part, this pre or operation things are somehow related to, again, analysis, capture, and also some kind of management, especially when you have these kind of test report, like commission test report, validation test report, or the cybersecurity audit report. So these information, they need to be there in a way that they actually supplement your safety SRS, your safety requirement specifications. The safety requirement specifications should actually make references to these informations, to these kind of report if necessary, if you have these kind of report. So, and after you have built it, you have installed it, now you need to run it. The operations and the maintenance, and during your operation, you might realize that something might go wrong that actually require you to have some kind of modification. You need to have some kind of MOC. And when that happens, we actually need to go back to the appropriate step. Usually, it's actually the same: analysis, capture, and manage. Usually is actually going back to the analysis phase, where you have to do a lot of like a new HAZOP or a new LOPA, select a new seal level for that particular sieve, because you realize that there are more safety incidents than you anticipated, maybe when you try to run the plant. So that would be related to those little bubbles within the data management lifecycle. When it comes to the operation and maintenance, it's mainly about capture and manage, because the analysis would mainly be done whenever you realize that there is a modification needed right over there. And then finally, you try to decommission your SIS, your SIS, usually one particular sieve. You want to overhaul it, whether you want to replace it, and that is the time when the old information needs to be destroyed. Any information about your old sieve. So this is very much resonate with the destroy in the data management lifecycle. So as you can see, the main focus of that particular of the lifecycle in IEC 61511, everything actually goes back to the safety requirement specifications. In fact, it is actually something that's very, very is actually required and also very, very important in the IEC 61511. It should contain all the requirements for the safety instrumentations, safety instrumented systems, and safety instrumented functions as well. So in a way that the objective of this particular SRS is basically trying to specify all the requirements, and also the requirements, whether they are functional, how is actually going to work. Like, are you going to open a valve or close the valve? Opening a valve or closing a valve, which one is actually going to prevent that particular hazard? So these are the requirements that needs to be outlined within the SRS. And there are also integrity requirements, which is basically related to the seal level, and also how quickly it should work. What is the process safety time? How quickly your valves needs to be closed? And in that case, it can be something related to how you're going to set up your PLCs, or maybe it's actually going to be related to the instrument that you choose, whether the valve can actually close it within that particular time. So these are very, very important things that goes into the whole design of your safety system. And that is the archive part. in the IEC 61511. And that is a very brief idea into the IEC 61511 lifecycle. Now let's go into the alarm management lifecycle. So the alarm management lifecycle is associated with the ISA 18.2. Again, everything starts with a plan, the philosophy documents. Basically, it outlines all the guidelines and practices, procedures of your alarm systems. And after you have set out that particular guidelines, then we try to identify those alarms. Usually it's a download of those alarms. And then we go into the rationalization process. The rationalization process focuses on reviewing all the alarms, like for each of the alarms, what are their cause, consequences, corrective actions, the time to respond. And then we also try to seek the set point and also priorities, these kind of reviews on that particular alarm as well. And then finally, we can, after the rationalization, we will be able to build a master alarm database. And in fact, whenever we talk about alarm management, it is very, very, very closely related to data science, because we are actually holding and also managing a database of alarm. Database of alarm as in usually at least up to 10,000 alarms, 20,000 alarms, and I've been to plants that they have 100 to 100,000 of alarms within that particular database, within their control system. So the idea of proper managing these kind of alarm data, and as you would know, that each alarm has different data, causes, consequences, corrective actions. So all these informations need to have a proper management of them. And that's why data science and also data analytics are very, very important whenever we talk about alarm systems. And after the rationalization process, we're going to go into a more detailed design process, which is related to some kind of programming of the alarms. For example, you have a compressor trip. Usually, when a compressor trips, that's going to create a lot of associated alarms, like the vibration alarms, high pressure, low pressure. They can come in both, whether depending on how you set them up, whether they're on discharge or whether they're on the inflow into the compressor. Usually, compressor has some other equipment kind of associated. There might be some filter, and maybe they would set up some kind of alarms as well. Even pressure, temperature, those are also going to come in place. So what we're trying to do during the detailed design is basically identify the first alarm that's going to come in, and then we try to silence the rest of the alarms, so that the operator is not going to be overwhelmed when they see a sea of alarms coming in at the same time. And then we're trying to, after we did all the designs, detailed designs, after we have done all those, we're going to basically implement that. We're going to put that back, upload that back to your control system. And then we are going to go into operations, maintenance, and do some monitoring and assessment, trying to see if there's any problems. If there is any problem, then we are going to have some MOCs, the management of change, to basically go through this rationalization process again. And also we have the audit right over there to do periodic check to see whether those activities are actually being done or not, mainly. The first philosophy part of this life cycle, as I mentioned, is about planning. The identifications is about capturing and also managing your alarm data. You try to capture these kind of alarms, whether they are from your download from your control system, or whether they are some kind of recommendations from the HAZOP. Usually HAZOP, they love to say, please consider add a new alarm there. Please consider add a new alarm here. So that's a very common recommendation. So that's usually create a lot of problems when we come to the rationalization over there. And during the rationalization process, we are going in very in-depth analysis to look at the set point to try to derive the priorities based on the severity and also the operator's urgencies. And also we try to archive everything because we are trying to set up a master alarm database here as well. And within the detailed design, we're basically trying to analyze, capture, and also try to manage these kind of alarms for better alarm management in that sense. And when we try to implement them, basically we're trying to manage the alarm, basically manage them to have a proper management, to have a master alarm database setting, and also have a different configurations back in the well, they actually should be identical configurations. Unless there's something that's go wrong, then there would be some kind of a problem within your control system when you try to upload these information back to control system. And there, I actually met some situations that the master alarm database with some of the attribute like your corrective actions for the operator, the whole part of that is missing when they try to upload that back to the control system, and that creates a lot of problems. So that's why proper data cleaning and also data management, data parsing is very important. And that kind of information, that kind of knowledge is very, very important when it comes to alarm management. So in a sense that you actually need to know a little bit of coding and programming whenever you do alarm management. After you have uploaded everything back up, you're trying to do the operations, maintenance, and also the monitoring assessment. This is actually very interesting part of the alarm management lifecycle, because here you're actually going to look at different performance indices. You can compare them to the KPIs that you want to follow, or you can actually try to set up your own KPI, or maybe you have some of these kind of informations and plot them in a way that in graphs, in bar chart, or in whatever kind of visualization means that you want, so that it can help you to identify whether there is a need for any kind of management of change. And during management of change, you're basically going through all the rationalization and design again. So you're doing the analysis again in that sense. And a periodic check is also related to analysis. It's going to talk about, look at your basically whether you have done these activities or not. And as you can see, the destroy is actually missing here, but there is actually a part of the ISA standard that's talked about how do you decommission alarms. So it's not exactly in the life cycle, but it's definitely within the ISA standard. And as you can see, the archive part of this alarm management lifecycle is mainly about the master alarm database. The ISA standard requires some of the informations that's required within the MADB, but some of the information they are just being recommended. And this MADB needs to be an authorized list because you have rationalized it. All the settings, configurations have gone through the rationalization process. So this is a whole authorized list of rationalized alarms and all the configuration as well. So whenever you do a download from your control system and you compare that with this MADBs, which should be static unless you go through another round of rationalization, and you realize that comparison actually create some kind of discrepancy between your control system and your MADB. That means that someone did some unauthorized changes within your control system, and that is usually when you're actually going to do the monitoring assessment, and also maybe you actually need the management of change, whether you actually want to bring those change into the MADB, or maybe you just don't want those changes at all. And then you need to override the changes within the basically reverted back the same state as the MADB when you try to upload that back to the control system. So in summary, the data management lifecycle, whenever we try to compare that to the functional safety lifecycle, we're talking about the information control about about your safety system. And the main archive is the SRS document. And when we talk about the alarm management lifecycle, the main information is about your alarm system. And then the main archive is the MADB, the master alarm database. Now you think that, okay, there are a lot of information, there are a lot of data. How exactly we can actually manage it well? And that's where we come in, where our Excellentia suite come in. As I mentioned, that is actually what we aim to achieve. We try to build a data core, basically a place where you can find all your data related to your safety system, so that information from PHA, maybe you list some of the alarms as safeguards, can easily be actually imported or maybe flown into the SIL alarm whenever you do the alarm rationalization. Our fax is also very famous for its easy use interface, especially when it comes to all these different cells. These different cells, they have associations. They're not just like one particular cell on the Excel. They actually associated with one particular data point. Like a safeguard here, high pressure alarm, whenever you use this safeguard, and you want to use it again on another consequence, you can link that safeguard to another consequence. And these are actually the identical data point within the software, so that any kind of changes here is going to actually affect that. So everything is linked together, and in a way that everything is, the data core is right over there within one place. And we also have the LOPA X, which is for LOPA analysis. We can do a lot of the SIL selection over there, and we can also do other kind of quantitative analysis over there for particular IPLs as well. Because LOPA, the main purpose of LOPA was actually to basically look at the IPLs and the quantitative analysis. It wasn't just for SIL selection. A lot of people had the misconception over there, but it was actually used to, you actually use it to analyze some of the like ignition probabilities or other kind of probabilities based on your plant's usage as well. And SRS, very important. We have our SRS module. We have our SRS, this Excellentia design SRS module, in the sense that we have all the blank that you are free to fill in all the blanks in a way that these blanks are actually being outlined within the IEC standard that they are either required or recommended to have for your design of your safety system. So everything can be as easy as a fill in the blank activity for you, so that you can archive the information much easier in that sense. And this is our silver module. Silver module, as I mentioned, is using the Markov modeling to do the calculation of the PFD average, and also TTFS or other kind of information as well. From this module, you can get the all the three barriers for your SIL verification, the PFD average barrier or PFH, depending on your demand mode, and then you have the SIL architectural constraint, and also the SIL systematic capability. So it might sound like French to you, or some kind of alien language to you. If that's the case, I would really recommend you to go into our functional safety courses to understand what exactly we're talking about, because these 3 barriers are actually required by the IEC standard for that seal level. A lot of people, whenever they do seal verifications, they actively ignore the seal architectural constraint, especially the seal safety system capability. They just don't even treat it as existed. So in that case, you are not really compliant with the IEC 61511, even though you did the PFD average calculation over there. So we also have the seal stat. So the seal stat is basically capturing all the information from your maintenance, from your operations, in a way that, if, for example, if you don't really have any failure rate data or any kind of certifications for your instrumentations, then after operations for a while, they can actually use the data that you have collected yourself to basically do certification yourself, and then try to argue that in a way that it's proven in use in that sense for your application. And this is a permittable route that is being I would say being outlined within the IEC 61508 and IEC 61511 standards. So that's the main part about the functional safety. Of course, about the alarm side, we also have our own software, the seal alarm. The seal alarm is set up in a way that is really nice, that you can design your own workflow, but it also lists out what are required, what are the information that's required by the ISA standard that's within the software. Within the standard, and it's also within the software, like the causes, the corrective actions, or the set point, what would be the priorities. That would be something that when we try to derive the priorities using the severity and also the urgencies, what is the classifications? Be careful about classifications, because classifications is not just a label. It's going to determine whether you actually need to maintain them or whether you need to do training on them, and also determine the frequency for those maintenance and training as well. And also, very importantly, what is exactly the set point of the alarm? If you have all these information but no set point of the alarm, all the activities that we have done for the alarm side is basically moot. And the whole seal alarm is designed in a way that it's basically a database. So you can keep seal alarm as your master alarm database to safeguard all your alarm configuration, alarm system information after you have done the rationalization. And we usually use seal alarm during the rationalization to facilitate that particular workflow as well. And that is the main gist about how exactly we can actually understand how exactly we can apply the data management lifecycle into functional safety and then also into alarm management. So what I talked about are just very brief introductions. If you guys are interested, you're welcome to join our courses. We have online self-paced training on functional safety, on alarm management, and even on the cybersecurity side as well, and automotives as well. We also have some live courses upcoming, live courses. We have online ones, and we also have an in-person in our headquarters in Sellersville in Pennsylvania, that we have an in-person live course in December from 6 to 9 in 2022, but at the end of this year. So if you're interested, welcome to contact us. Right, welcome to look us up on Twitter, Facebook, and LinkedIn. Because today I've basically used up all the time today. I'll try to answer any question through the emails, and if you can also send me any email for any extra questions. And I hope that you have got something and also learned something new today. And I'm really grateful that you guys joined with me for today's session on the webinar. And I hope that you guys have and basically enjoy the rest of your day. Hope to see you guys next time. Thank you very much. Bye-bye.